Hi, I am Harini from Savita Engineering College. I am pursuing my first year in Bachelor of Technology, Artificial Intelligence and Machine Learning. Today I explain about the program QR decomposition. Decomposition is a method for breaking down a matrix into two special matrices, Q and orthogonal matrix. This means that its columns are perpendicular to each other and have a length of 1, or an upper triangular matrix. This means that all the elements below the diagonal are 0. QR decomposition is often used in numerical linear algebra to solve systems of linear equations and find eigenvalues. It also used in machine learning for tasks like solving linear regression and handling overdetermined systems. Here is a visual representation of QR decomposition. In the image, the matrix A is decomposed into the product of two matrices Q and R. The matrix Q is an orthogonal matrix and the matrix R is an upper triangular matrix. For QR decomposition. Code breakdown. Import NumPy. Import NumPy as NP. This line imports the NumPy library which provides tools for numerical computing in Python. Function definition. Def QR decomposition A. This defines a function named QR decomposition that takes a matrix A as input. Get matrix dimensions. N, n is equal to A dot shape. This line retrieves the dimension of the input matrix A. N represents the number of rows and M represents the number of columns. Initialize matrices. Q equal to np dot empty n, n creates an empty matrix Q to store the orthogonal matrix. E is equal to np dot empty n, n creates an empty matrix U to store intermediate vector during the Gram-Smith process. First column of Q. U square bracket of semicolon comma 0 is equal to A square bracket of semicolon comma 0. Assign the first column of A to the first column of U. Q square bracket of semicolon comma 0 is equal to U square bracket of semicolon comma 0 slash np dot linear algorithm norm U square bracket of semicolon comma 0 square bracket normalize the first column of U to obtain the first column of Q. Gram-Smith process. For I in range 1, n. This loop iterates over the remaining column of A. U square bracket of semicolon comma I is equal to A square bracket of semicolon comma I. This assigns the current column of A to corresponding column of U. For J in range I, this inner loop performs the orthogonalization step. U square bracket semicolon comma I minus is equal to A square bracket semicolon comma I at Q square bracket semicolon comma J star Q square bracket semicolon comma J. Subtract the projection of the current column of A onto the previous orthogonal vector from the current column of U. Q square bracket semicolon comma I is equal to U square bracket semicolon comma I slash np dot linear algorithm dot norm U square bracket semicolon comma I square bracket normalize the current column of U to obtain the corresponding column of Q. Compute R matrix. R is equal to np dot 0 n, n creates a 0 matrix R to store the upper triangular matrix. For I in range n, this loop iterates over the row of R. For J in range I, m, this inner loop iterates over the column of R starting from the current row index. R square bracket I, j square bracket is equal to A square bracket semicolon comma j at Q square bracket semicolon comma I computes the elements of R using the dot product of the corresponding columns of A and Q. Print results. Print the Q matrix is slash n, q. Prints the computed orthogonal matrix Q. Print the R matrix is slash n, comma R prints the computed upper triangular matrix R. Get input and call function. A is equal to np.array eval input prompts the user to enter a matrix and converts it into a NumPy array. QR decomposition A calls the QR decomposition function with the input matrix A. In summary, the code implements the Gram-Schmidt process to compute the QR decomposition of given matrix. The resulting matrix Q and R can then be used for various numerical linear algebra applications. This is the output for our program. Thank you.